All right, we're in section 4.6 of Al Grosch's book, Developmental Math 2. In this video, we're going to talk about multiplying polynomials. All right, multiplying polynomials, to start off basically, can be monomial times monomial, monomial times binomial. In this example, we have a monomial times a trinomial. And just to review that vocabulary, a monomial has only one term, so this is all one term. A trinomial has three terms. Anytime we multiply a monomial times any other polynomial, we use distributive property. So you can do this distributive property in three pieces. That's how I like to think about it. The first piece would be to identify the sign or multiply the signs. The second piece would be to multiply the coefficients. And the third piece would be the variables. And when you multiply the variables, you add the exponents. So we're going to start off with this example here. 2x to the fourth times 3x squared minus 4x plus 5. And we're going to use these three steps to do the multiplication. So first, this monomial times this term would be positive times positive makes positive. So the first term is going to be positive. And you can write the plus sign if you want, but you know you don't really need it. Then the coefficients, 2 times 3 is 6. And then the variables, x to the fourth times x squared. And when you multiply the same variable, you add the exponent. So this is going to be x. And then when I add the exponent, 4 plus 2, I get a new exponent of 6. So that's the first term. So that's this times this. Then we're going to do this times this. The signs first. Negative times positive times negative makes negative. 2 times 4 is 8. X to the fourth times another x. And don't forget this x has the invisible 1 on it. That makes x to the fifth. And then we're going to do this times this. Positive times positive makes positive. And in this case, you do need the positive, because it is the sign that is separating the terms. Up here at the front, you don't need the positive. It's okay to write it if you want. You don't have to. Then the coefficients, 2 times 5 is 10. And then the variables, x to the fourth. Now, there are no more x's here, but that doesn't mean we're going to drop them all off. We still have this 4 here. There just aren't any more to add with them. So we're going to have x to the fourth. And that's how we multiply a monomial times a trinomial. We have a few examples further down here. We're going to do this again, same way. We're going to first do the sign. Negative times negative makes positive, and again, you can write it if you want. 3 times 1 is 3. X squared times x to the fourth. Add those exponents, you get x to the sixth. Then here, negative times positive makes negative. 3 times 3 is 9. X squared times x squared, add those exponents, you get x to the fourth. Then here times here. Negative times negative makes positive. 3 times 1 is 3. X squared, and there are no x's to add on, so you just have the x squared from the monomial at the front. After we work distributive property, we always look to see if there are any like terms, because we're not done unless the like terms are all simplified and added together. But this is x to the sixth, x to the fourth, x squared. They are not like terms, so we're all finished. So down here we're going to do the same thing. Negative times positive makes negative. 5 times 3 is 15. X cubed times x squared, add those exponents, you get x to the fifth. And this time we have another variable, y times y fourth. And don't forget, this y has the invisible 1 on it. So this is going to make y to the fifth also. Add those exponents, 1 plus 4. All right, then we're going to do the next term. Negative times negative makes positive. 5 times 7 is 35. X cubed times x squared. Add the exponents, we get x to the fifth. Don't forget, though, we have this y here, and there are no more y's down here to put with it, but we still have to bring that y into our product. So we have a y here. Then we go here times here. Negative times positive makes negative. 5 times 4 is 20. X cubed. There are no x's here, so we just have the x cubed. Y1, y cubed. Add the exponents, we get y to the 4th. That's it for that term. Got one more term. Negative times negative makes positive. 5 times 2 is 10. X cubed. There are no variables down here, so we just need to carry these ones from the monomial at the front. X cubed, y to the 1. All right, on this page, we're going to multiply now a binomial times a binomial. And if you remember that vocabulary, a binomial is a polynomial that has two terms. So 2 terms in this polynomial make it a binomial, and this one also. 2 terms make it a binomial. You may remember from high school, if you took algebra in high school, that the FOIL method stands for first, outer, inner, last, and you can use this method to multiply a binomial times a binomial. It just means multiply the 2 first terms together. So 3x times 5x, then multiply the outer terms, so that would be 3x times negative 9, that gives you negative 27, then the inner terms, 2 times 5x, gives you 10x, and then the last terms, and FOIL is an acronym that stands for those, first, outer, inner, and last. 2 times negative 9 is negative 18, and then you have to look through here and combine like terms. Where are the like terms? Right here in the middle usually. So we end up with a negative 17x from combining those like terms. So our product will be 15x squared minus the 17x from combining the terms in the middle, and negative 18 from the last terms there. I don't like this acronym FOIL. It really only applies in this one situation. I prefer to call this double distributive. It's not written here in your book as that. That's what I call it, double distributive, because what you're going to do, and I'm going to write this example over here again, 3x plus 2 times 5x minus 9, is you're just going to use distributive property. You're going to distribute the 3x to the 2 terms in this binomial behind it, and then you're going to distribute the 2 to that same binomial. So it's double distributive because you're distributing 2 different terms from the front binomial to the back binomial. It turns out to be the exact same thing. I just like this term better than FOIL, but if you know it as FOIL, it works. You can use the acronym FOIL. I'm going to call this double distributive. So that's what we're going to do now. We're going to distribute. So we're going to multiply 3x times 5x, and using the same procedure we just used on the previous page. Positive times positive, then coefficients, then add the exponents on the variables. So we'll have positive 15x squared from multiplying 3x times 5x. Then 3x times negative 9 gives us a negative 27x. Then, and that's just distributing 3x. Then we distribute the 2. 2 times 5x gives us 10x, and that's a positive 10x. 2 times negative 9 gives us negative 18. Then we look for the like terms. They're generally here in the middle, usually, but not always. When we combine those, we get negative 17x. We have a 15x squared here at the front and a negative 18 at the back. Of course, it turns out to be the same exact thing as FOIL over here. Otherwise, the two methods wouldn't work together. You can use either method. I'm going to use double distributive. I'm going to call it double distributive because that's my preferred method. In your book here, we also have what's called the table method. If you learned it this way, I'm just going to review it real quick. It's really great to keep your multiplication organized. If you did not learn this already, I do not suggest you try learning it now, but I'm going to go over it briefly. If you want a review of it, you have pages in your book, tables in your book if you want to use them. I don't use this method, but I'll review it for you. 3x plus 2 is over here, and the terms are separated 1 term per line. 5x minus 9 across the top, again, 1 term per box. And then inside here is the multiplication, similar to when we used to do multiplication with just whole numbers when we were younger. 5x times 3x makes 15x squared. And that is an exponent there. It doesn't look like it, but it is. And then 5x times 2 makes 10x. Negative 9 times 3x is negative 27x. Negative 9 times 2 is negative 18. Same terms. You look for the like terms. Comes out to be the same exact thing. The table is really just a way to keep yourself organized. If you need it, if you like it, if you've learned it before and you want to use it, you've got space here in your book to do it. I'm not going to use the tables. So on this page, we're going to do x minus 5, a binomial, times another binomial, negative 3x minus 8. And I'm going to do double distributive. So x times negative 3x is negative 3x squared. X times negative 8, negative 8x. Then I will distribute the negative 5. Negative 5 times negative 3, so negative times negative makes positive 15x. Negative 5 times negative 8, positive 40. There are generally like terms here in the middle, so I'm going to add those. Negative 8x plus 15x makes positive 7x. I have a negative 3x here at the front and a plus 40 here at the back. So negative 3x squared plus 7x plus 40. All right, and this is why I like to call this double distributive, because now we have a trinomial here, 3 terms, and your acronym FOIL won't work now that we have put this trinomial here. The table method still does. You have enough places on this table if you want to use it. You can put the trinomial across the top and the binomial down the side. But we're still going to do double distributive, which means I will still distribute this 4x to these 3 terms, and then I will distribute the 1. So let's do that part first. 4x times x squared is going to be 4x cubed. And then 4x times negative 6x will be negative 24x squared. And then 4x times negative 8 will be negative 32, 4 times 8, x. And then I'm going to distribute the 1. Distributing 1 is actually pretty easy because multiplying by 1 doesn't change anything. So we'll have 1 times x squared makes x squared, and I'm going to write this vertically. Instead of writing those terms over here, I'm going to write them underneath and line them up. I lined it up under this one because they're like terms. It just makes it easier to combine like terms. So then we're going to do 1 times negative 6x is negative 6x. And then 1 times negative 8 is negative 8. And now I can just draw a horizontal line and I can add these, and the like terms are vertical. So I can just add straight vertically down like this. So I'll have a 4x cubed, and then I'm going to add negative 24x squared, and positive 1x squared makes negative 23x squared. Negative 32 and negative 6x make negative 38x, and then just this negative 8 down here on the end. And we're done. So that's not too bad. All right, so you're going to notice already that I skipped the last multiplication on the previous page. So I'm going to put it at the top of this page instead. I have some white space up here I can write. That multiplication was a trinomial, 2x squared minus 4x plus 1 times 7x squared minus 3x minus 4. And it's on the bottom of page 161, the previous page. I accidentally forwarded and skipped it. So I'm going to do it here with you guys. So this is no longer double distributive now since we have a trinomial. It's triple distributive. So we're just going to distribute this first term to all 3 of these. Then we'll distribute the middle term. And then we'll distribute the 1. So it takes a little while, but we can do this. So we're going to distribute 2x squared times 7x squared makes 14x x to the fourth. 2x squared times negative 3x makes negative 6x cubed. 2x squared times negative 4 makes negative 8x squared. And that takes care of the first term. And then we're going to distribute this negative 4x. Negative 4x times 7x squared makes negative 28x cubed. And again, I'm lining them up vertically. Then the like terms will already be lined up when I get ready to add like terms. Negative 4x times negative 3x makes positive 12x squared. Negative 4x times negative 4 makes positive 16x. And then I'm going to distribute the 1. 1 times 7x squared is positive 7x squared. 1 times negative 3x is negative 3x. And 1 times negative 4 is negative 4. And now I'm ready to add vertically. So, and you can see my like terms are already lined up, so it's easy to add this vertically. I'm going to have 14x to the fourth, negative 6 and negative 28 make negative 34x cubed. I've got a negative 8 here, a positive 12, and a positive 7. It doesn't matter what order you add them in. You can add the positives together. 12 and 7 make 19, and subtract the 8 gives you positive 11x squared. And then we're going to add the x terms. Positive 16 and negative 3 make positive 13x. And the last term, the constant, negative 4. So that's what we get. That's triple distributive, when you multiply a trinomial times a trinomial. All right, so here we have multiplication, but it looks a little bit different because we have the square being used instead of the two binomials together. What I want you to recognize here is this is not the same as distributing the exponent inside. You can't do that. It doesn't come out to be x squared plus 9, folks. So make sure you don't do that. The only time you can bring a square inside is when there's no add or subtract. If it was 3x squared, then we could bring it in. There's no add or subtract. This is okay, but this is not, so don't do that. Instead, what you're going to want to do is you're going to want to say, okay, this is the exponent. The base is x plus 3. The exponent on the base means there are two of these. So there are two x plus 3s being multiplied together. And this is where double distributive comes in. We distribute the x, and we have x squared plus 3x. Then we distribute the 3. And we have another plus 3x plus 9. And then we look for the like terms, which are right here. 3x and 3x make 6x. We have a plus 9. We have an x squared at the front. So x squared plus 6x plus 9. And notice, it's not the same as this. Okay, so don't bring the exponent inside the parentheses if there are plus and minus signs. It doesn't work. If it's all multiply, yes, this is fine. This does not work, so don't do it. All right, on number 2, we have the same situation, a binomial being squared. So we're just going to write that binomial twice, 2x minus 5 times 2x minus 5, and we're going to double distribute. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Negative 5 times 2x, negative 10x. Negative 5 times negative 5 is positive 25. Negative times negative, so be careful of your signs. Combine like terms. Negative 10x and negative 10x make negative 20x. We have a plus 25 back here. We have a 4x squared at the front. So 4x squared minus 20x plus 25. Okay, we have 2 more examples on this page. A binomial times a binomial. We're still going to continue to do double distributive. So x times x is x squared. X times negative 3, negative 3x. 3 times x, positive 3x. 3 times negative 3, negative 9. And combining like terms in the middle, you're going to notice you have a negative 3x and a positive 3x. They cancel each other. They make 0. Negative 3 and positive 3 make 0. So your final product is x squared minus 9. This was the first time we saw this happen when we multiply binomial times binomial. Usually, when you combine these like terms, you get a middle term. But when you start with two binomials that are identical, except for with opposite signs, the middle terms will always cancel. And you end up with a new binomial. We're going to actually come back to this when we start factoring, because with factoring we'll start with the product and we'll be remembering the pattern that made that special product called the difference of squares. Okay, we're going to simplify here again. 4x times 4x is 16x squared. 4x times 1 is 4x. Negative 1 times 4x, negative 4x. Negative 1 times positive 1, negative 1. And we see we have the same thing happening here in the middle. Because we had two binomials that were identical with opposite signs, these middle terms cancel. Positive 4 and negative 4 make 0. And we end with 16x squared minus 1.